Hello, welcome to the second part of videos about binomial distribution. Before watching this, make sure you watch the video about Pascal's triangle and combinations. Okay, so let's use the skills we learned there to proceed. So the big idea we looked at in that last video was that we have this thing called Pascal's triangle with a very important number pattern in it. As you can see, 3 plus 3 makes 6, or 4 plus 6 makes 10, or 5 plus 10 makes 15. And to acquire every number in that triangle, we can use something called a combination. So notice, for example, in row 4, all these values have been replaced with these combinations. And this is read like 4 choose 0, or 4 choose 1, 4 choose 2. And combinations formula looks like this, and that formula produces all these numbers here. Okay, that's what we've seen. So now let's move ahead. Looking at the page of notes where you ended before, let's start here. Fair coin is tossed, a coin that has a 50-50 chance of getting heads or tails, and let x represent the discrete random variable equal to the number of heads tossed in 2 trials. So again, if you flip a coin twice, how many heads can you get? Well, you can get 0 heads, 1 head, or 2 heads. What's the probability of each of those? Let's take a look. If you drew a tree diagram as it asked you to, we can have heads, tails here, 50-50, right? And then if you do a head on the first toss, then you have also the chance of getting a head or a tail on the second toss, and again 50-50. And same here, if you did a tail first, you can get a head or tail here also. So looking at this here, we can figure out there's probabilities. For example, if you go this way, tail, tail, that's a path that has tails, tails. That means 0 heads, because this is talking about heads. So the 0 heads path has a 1/2 times 1/2 probability, which is 1/4. Next, 1 head. Well, 1 head occurs in 2 places here. It's the tail head path or the head tail path. Both those paths lead to an outcome that has 1 head. So those 2 paths have a probability of 1/4 along each one, and then we add the 2. 1/4 plus 1/4 is 2/4, or 1/2. And finally, the path that has 2 heads, well, that's only the path on top here. So that path has a probability of 1/2 times 1/2, leads to 2 heads, and that's a 1/4 probability. So that's a probability distribution for this, and let's move ahead with that one. So next step, again, we have that tossing of a non-biased coin, the results we just looked at. And the question here is, how many paths lead to each of these outcomes? How many paths in this tree diagram lead to 0 heads, and how many paths lead to 1 head, and how many lead to 2? Well, we kind of just discussed that. We saw the 0 head path here. There's 1 path that leads to 0 heads, and 2 paths in the middle that lead to 1 head, and 1 path along the top that leads to 2 heads. So now, what connection do you see between that are the number of paths and Pascal's triangle? Do you see a connection? Okay, hopefully the connection you spotted was between these numbers and row number 2. And that's a very important connection. Basically, the number of paths leading to each outcome can be found in the matching row of Pascal's triangle. So we were tossing 2 coins, so therefore we're looking at row 2, and here is the chance of getting 0 heads, 2 heads, or 0 heads, 1 head, or 2 heads. So everything in order is here after you toss 2 coins. It matches these numbers here. Important connection, make sure you see that there. Okay, next. So again, looking at the same situation, what is the probability of obtaining 1 head? Well, we have calculated that already, but let's look at it in a slightly different way. So we have 1 head along this path, head, tail, and we also have 1 head along this path, tail, head. So there's 2 paths, and again, we know that you can multiply along and then say that path plus this path. But another way to look at it is, again, we had in row 2 of Pascal's triangle, we know that the middle number here here's 0 heads, 1 head, 2 heads. So 1 head is 2 paths. That number represents the paths. So we have 2 paths, which again is obtained from here. 2 paths, and each path has the same probability along it, 0.5 times 0.5. 2 of those, and we get the probability of 1 head. Okay, and again, this 2 path number can be obtained using a combination, because remember, all these numbers here can be obtained with combinations. So if you look at it, we need that number, we can just get it by saying row 2, 1, choice 1, right? This is row 2, choose 0, row 2 choose 1, row 2 choose 2. So that combination will give us how many paths there are. Let's take a look at another example like that. So now we're going to look at tossing a biased coin, which means a coin that's not fair. It means it's not 50-50. And if you look at here, we have 2/3 chance of getting a head, or 1/3 chance of getting a tail. So that's a biased coin. It's not fair. And then we're doing 3 tosses of that coin because we can see here 2 and 3 tosses. So for example, you can get head, head, head like that. Okay, so how many paths lead to each outcome this time? And now the outcomes are 0 heads, 1 head, 2 heads, or 3 heads if you get all 3 heads on all 3 tosses. So what are the numbers that go here? Okay, well here are the numbers. I hope you're able to see that from here. You can see that there's 1, 2, 3, 4, 5, 6, 7, 8. 8 total journeys or paths you can take through here, and these numbers add up to 8, so that makes sense. Now let's take a look at where they come from. Again, there's the connection between Pascal's triangle and these outcomes, or the number of paths. So the number of paths you can look are right here in row number 3, because we're doing a 3 coin toss, which is 3 trials. So we go to row 3 of Pascal's triangle and we see 1, 3, 3, 1. So that means 1 where there's 0 heads, 3 where there's 1 head, 3 where there's 2 heads, and 1 where there's 3 heads. And if you count it there, it makes sense. So now, what is the probability along the HTT path? So look at the head, tail, tail path, and what would be the probability along that single path? Well, that path is right here, head, tail, tail. So that path has a probability of 2/3 times 1/3 times 1/3 equals 2/27. Now, next question, what is the probability of obtaining 1 head? Well, you can see this path is one of the paths where you have 1 head, but there are a few others, right? We know that there's 3 right here, 3 1-head paths. So what's the total probability of obtaining 1 head? Well, again, we can say, well, here's another path, the tail, head, tail path leads to 1 head, or the tail, tail, head path also leads to 1 head. So there's 3 paths, which matches what we have here. And then, so 3 paths, and each path, now here's the important part, each of those 3 paths, even though this is not a fair coin anymore, it's biased, there's different probabilities, but each path does have the same multipliers along it, right? Because each time you have a head, it's 2/3, and each time you have tails, it's 1/3. So if we have a path that has 1 head and 2 tails, it's going to be 2/3, 1/3, 1/3. And it doesn't matter the order of these. Like if this H was in the middle here, then this 2/3 would be in the middle. The main point is that you're always multiplying by 2/3 and then 1/3, 1/3 twice to get a path that has 1 head. Because the 2/3 is the head and the 1/3 times 1/3 is the 2 tails. So 3 paths with identical probabilities, and that will give you your total probability. And that works out to this number here, 6/27. And remember, the 3 paths, to figure out how many paths there are that lead to that outcome, we just do 3 coin tosses, 1 head, 3 choose 1. And from here, it's row 3, this is choose 0, this is choose 1, right? Choose 0, choose 1, choose 2, choose 3. So choose 1 is here, and that's 3 choose 1, which is 3. That number produces our 3 paths. Okay, so we can see the paths here, but it's important to know that the combination will give you the number of paths every time. Alright, that leads us to a very important rule. It is called the binomial distribution rule. It looks like this. Please pause the video now and just read through that, see if you can make sense of that. Okay, have you paused? Great, I believe you. I believe you've read that. Now this formula looks a little complex, but basically it's exactly what we've been just looking at. So let's look at it one more time here just to see how this formula comes to life. So let's find the probability of 2 heads obtained when flipping a coin 3 times. So again, here is our 3 coin toss, and it is biased, and we want 2 heads. So we're going to use this formula. The first part is the combination. So again, we're looking for probability of getting 2 heads, x equals 2. Here's the first part, the combination. The combination will always tell us how many paths here lead to what we're talking about, right? In this case, 2 heads. So we have 3 is our number of trials, or 3 coin tosses, and we're looking for 2 heads. So 3 choose 2. 3 choose 2, if you work it out, will be, let's see, what that number is. That number is 3. And 3 means there are then, remember that combination always represents the number of paths. That means 3 paths here will lead to 2 heads and 1 tail. And each path looks like this. 2/3 squared times 1/3. And why is it 2/3 squared? Because a 2-head path will be head twice, and twice is 2/3. So 2/3, for example, times 2/3, there's your double 2/3, and then 1/3 for the tail. And again, the order doesn't matter. You could have gone head, tail, head. There's still 2/3 twice and 1/3 once. So that remains the same along each path, and there are 3 paths. Really important to understand how that works, so pause now, make sure you get the details of that. That answer, by the way, is 12/27. Okay, let's continue here. So these are also in your notes. We're going to do these 2 questions in class. We're going to look at these 2 right now. So see if you can solve A. Give it a try using the formula we were just talking about. Think of the paths and think of the probabilities along each path. Okay, so this one is solved in this way. First of all, we can write it. When something is a binomial distribution, it means there are 2 options possible. And in this case, there's the option of getting a question right or a question wrong. So that's binomial. And in this here, we can say the variable x is distributed with a binomial distribution. There are 6 trials because there are 6 questions in this quiz, and each correct answer, to get a correct answer, you have a 25% chance because you have a 25% chance of randomly selecting one of the 4 correctly. Okay, so now to set it up, we want to find the probability where x equals 2. So what's the chance of getting 2 correct answers? So how many paths are there? Well, 6 choose 2, because 6 is how many questions you're doing, and we're trying to select 2 we're trying to do 2 correct answers. So out of 6, we want 2 correct. So that's how many paths there are that are going to lead to 2 correct. And then along one of the paths to a correct answer, we're going to have to do 0.25 times 0.25, because there's a 0.25 chance of getting one of these as the correct answer, and then that will happen twice to get 2 correct answers. And then in the situation where you get 2 questions right and 4 wrong, well, to get a question wrong is a 0.75 chance, because 3 out of 4 of these will be wrong. Like BCD, for example, could be wrong. So 75% chance you'll be wrong, and there are 4 times you're wrong, because again, we're looking for a situation where 2 are correct, so 4 are wrong. So again, the correct ones, the wrong ones, there's 1 path, and this tells us how many paths. That's 6 choose 2. If you did the formula, you know it works out to a certain number. Multiply that number by this, and you should get this probability. Again, if you forgot how to do this, you can look in Pascal's triangle, or you can use the combination formula from the previous video. Okay, let's look at part D. Try this one out. Oh, sorry, no, part C. The red ones we're going to look at in class. So part C, try that. Well, in C, basically you have to say if it's x is less than 2, it means we're looking for probability of x equals 0 or probability of x equals 1, because those 2 things are less than 2. So then you'll repeat this formula for this one and this one. So you can write it out twice. 6 choose 0, so that means you get none right, and then you multiply that, none right, so 0 of those, and all 6 of them are incorrect. And here 6 choose 1, so 1 correct out of 6 questions. There's 1, and there's 5 that are wrong right there. Combine all that, and the answer is this value right here, 0.534. Okay, a couple more. Look at this one here. Read that and see if you can set it up. Okay, in this one, we're familiar with these coin ones already, so now we're looking for a coin when you get tails. Let's see, coin is the number of tails. Sometimes A is the number of tails. Okay, A is the number of tails. So we're looking for A to be equal 5. 5 tails. We're doing 7 flips of the coin, and we want 2 to be heads. Okay, because probability of, did I do this right? Let's see, probability of heads, 7 choose 2. Maybe something's not right here, but this is the correct answer, so check your work. I'm going to double check this, and I'll get back to you on that in one moment. Okay, but this answer is correct. See if you got there. And now these questions we'll do in class, B, C, D, and one more for you to try here. Of these, I want you just to look at A, part I. These other ones we'll do in class. So in a family of 6 children, find the probability there are exactly 3 girls. Alright, and here's the way we set it up. We have 3 girls, so 6 kids, 3 girls, equal probability girls and boys, so 0.5, 0.5. Alright, let's talk more in class. Great job with this today.